modeling and image processing, hybrid energy harvesting system, design of sensors, and the development of intelligent ROVs and AUVs for inspection and monitoring. We heartily welcome you for this session, sir. Thank you for accepting our invitation. Thank you, sir.
Okay, thank you. Can I have your attention, please? Yeah, next 1 hour I'm just going to talk something related to, I don't know from which background you all are, whatever may be your background, right? I'll just connect everyone with respect to ocean or ocean engineering. How you see ocean or how you have seen ocean till now. Maybe after 1 hour, you can have a different version about how you can see ocean in future. That is what is my primary objective of I am here, and hope from yesterday you would have come across various technologies and various happenings that are happening along the coastal regions. Now I just want to know in another 1 minute, 60 seconds, what have you learned in the past 1.5 days as far as this topic is concerned, the rise of blue finance or something related to ocean technology. Because I know the speakers are from National Institute of Ocean Technology, all have very good experience, and they would have just transferred the knowledge on the current scenario that is happening as far as this technology is concerned. So may I know what is your take home from yesterday and from today morning? If there is nothing, then I can come to a conclusion that there will not be nothing after 1 hour also. If there is something that you have taken, then can you just brief out as a bulletin point? It is enough if you just come out with a bulletin point, because I don't want to repeat the same what other speakers would have discussed. What are the various challenges in ocean then? Very good.
Then what is the technology that is being used, deep sea technology that is being used to measure the parameters?
Okay. Image restoration by Dhanlakshmiya. By Dhanlakshmiya. Right. She is my student. She is my PhD student. Okay, she graduated now. Right, then. Okay. Then I don't think so that I have something new. As the second title says, then I will just discuss on some of the case studies, how we can collect the data. I just don't want to go by the slides, because the slide is compiled in such a way. First it will give an introduction about ocean, as you rightly mentioned, the challenges in ocean, and then what are the various applications. Though the ocean has various challenges today, but still people like to do research in this ocean technology. The reason why we want to work in this ocean technology, and further about the sensors. What are the various sensors that we have with respect to this ocean, and then few case studies. This is what I have planned. So the most important thing as far as my topic is concerned is about the signals. What type of signal that we can use in ocean. So for that we have to go back and understand what is ocean. Without understanding what is ocean, you cannot relate the technology, how it is being used. So most of us would like to spend our time in the beach area. Because of what reason? It is so pleasant. It is so pleasant. So whatever tension we have, we can freeze out the tension, and we may not know the time. So obviously it will make us comfortable. But if you see from the other side of the ocean, it is totally different. It is not so romantic as how we see from the shore. It is the most dangerous person. Okay, so first we have to understand what are the hazards that the ocean has. Only then we can understand the technology or the deployment of the technology. I'll just want to give a simple example to you. You drop a coin in the ocean. What is the probability that you will retrieve it back? You just drop a coin or any object of your interest, right? Even if you just want to wet our foot in the ocean, the first precaution what we take is, we take care of our chappals. Yes or no? Because we don't want it to go along with the water. Why it goes along with the water? We are able to feel the force at which water is coming to us. But even then, we are very cautious. We don't want our and we have hold through our fingers. Though we have hold through our fingers, still we can see that we are not able to retain the chappal with us. Now you see, it is one of the most simple thing which you can see. I am not going to talk about deep ocean. I am not going to talk about something you sail into the ocean. Why we are taking such a cautious steps? Then imagine you just drop a coin, right? I would like to talk about two things. One is dropping a coin, whether you are able to retrieve it back. Second thing is the coin which you see in the floor of the water, whether it will be in the same position from where you see. For example, if I drop a coin here, I can exactly tell where it is. Whereas if you drop the same coin in the ocean, whether it will be in the same line? Obviously no. So the second one is for the basic principle. First one is for the hazard or the danger. How we should be careful when we are working. Now how I want to relate this is very simple. If I deploy a sensor in ocean, what will happen to the sensor? Instead of coin, the reason why I consider it as a coin is very simple. For example, if you go for a small sensor, an acoustic sensor, a passive sensor, its size will be similar to that of a coin. And it is a piezoelectric element. So the weight will be few grams only. The weight of the sensor will be only few grams. So what will happen if you deploy that few gram weight sensor in the ocean? Will it be in the same place? Obviously, the probability of the sensor in the same place is very less. As I said, the second case, I drop it. What is the probability that I will retrieve it back? What is the probability that I can get it back? Obviously zero, maybe from your understanding, but from the researcher point of view or people those who are working in the technology, we would like to have it or make it as 100%. Otherwise, we have lost it. Once dropped is dropped. We cannot retrieve it back. So the probability should be made from 0 to 100. That is what is the challenge. The probability should be inclined from 0% to 100%. So how you can do that is the big question. When I want to do it, what are the parameters that will come across in the channel? First thing is we have to study the channel. What is an underwater channel? As madam has rightly said that you have come across the challenges. What is the major challenge in ocean technology or underwater? Very good. So the first and foremost thing is pressure. How much pressure? How much pressure? It's a calculated value. How much pressure? It would have been discussed. For every 10 meters, it will be 1 bar pressure. For every 10 meter, it will be 1 bar pressure. So obviously, you have to withstand 1 bar pressure. What is the maximum depth of Indian coastal region? Indian oceans? Along the coastal regions of India, maximum depth is 6,000 meters. Maybe in deep sea ocean, they would have discussed this. 6,000 meters. If I want to deploy a sensor at 6,000 meter depth in the ocean, open sea, then the particular sensor should withstand how much pressure? 600 bar pressure. So it has to withstand 600 bar pressure. You can just imagine, for example, the 600 bar pressure is almost equal to a giant elephant standing on your toe. It is almost like a giant elephant standing on your toe. I don't know how many in this classroom can withstand that weight. Okay. And another case study, how I can relate it. In case if you just go with a bare body, if you want to swim at around some 10 bar pressure or 20 bar pressure, obviously you can feel that the bones are cracking. Because our human bones cannot withstand that pressure. With a bare body, we cannot withstand that pressure. Now you just think about a coin size of few grams of a sensor should withstand this pressure. You cannot remove the pressure out and then deploy the sensor. The pressure will exist there. So you have to withstand that pressure. That is number one. Number two, the channel. What is the characteristics of the channel? Is purely dynamic. It is not static. It is purely dynamic. Why it is called purely dynamic? For example, if I deploy a sensor at this particular instant of time in this location, consider as a open sea, offshore. I know the particular location, I know the particular depth where I am going to deploy the sensor. I will deploy the sensor, I will collect the data. Next day, same time, same location, you deploy the sensor, collect the data, there will be difference in data. Both the data will not be same. There will be minimum difference in the data because the channel will be purely dynamic. For your understanding, let me tell you, it is a water flowing system. The water keeps on flowing. I can relate it with an example, tide. Can you calculate the tide? Whether tide will be same today at this time in this location, this will be the tide. Tomorrow at the same time, same location, whether it will be the same tide? Yes or no? Obviously no. So this is one simple parameter. Another one is wind. Whether it will be same? Both are natural phenomena or man-made phenomena. So the channel is purely dynamic. Now the channel can be dynamic. The sensor, whether it should be dynamic or static? It should be static. Now you see one fellow is static, another fellow is dynamic. Now I have to map these two fellow. Unless otherwise I map these two fellow, I cannot interpret the data. It will be very difficult for me to interpret the data. So basically we have to understand all these things before we deploy our sensors in underwater. This is number one. The reason why I directly went to sensor is our topic is wireless communication, right? Now coming to the next one, what type of signal? Obviously by this time you may be knowing. Which is signal? Not optical, but acoustics. Optical we can use, but the most commonly used is acoustics. Acoustics is a high frequency or low frequency? It's a low frequency signal. For example, what is the frequency at which your mobile phones are working? What is the frequency at which you are using your mobile? Hope everyone will have a mobile. What is the frequency? 2.5. Hope you may be in final year now. And a project 2.4 gigahertz free license, correct? 15 வருஷமா இதே தான் சொல்லிட்டு இருக்கீங்க. 2.4 gigahertz is for Bluetooth. Okay. I asked about your voice communication using your mobile. It is not license free. Voice communication is not license free. That is the reason you are paying every month. What is the frequency? Very good. 700 to 2100 megahertz. Very good. It's a very wide band. Very wide band. Okay, but actually our voice frequency using mobile we use 800 to 900 megahertz. Okay, right. Satellite communication, general satellite communication. Don't guess always. 6 to 4 gigahertz. Optical communication, ten gigahertz. Okay, to some extent you are close. It is in terahertz, 10 to the power of 12 to 10 to the power of 14. Okay, now what I am trying to tell is megahertz, gigahertz, terahertz, 10 to the power of. Whereas when you come to this underwater communication, it should be in hertz. It should be simply in terms of hertz only. For example, what is the voice frequency of human being? What is the voice frequency of human being? Very good. This is the answer I expect. 20 hertz to 20 kilohertz. Correct? That is audible frequency. Voice frequency is vocal cord frequency. It is 3 to 4 kilohertz. Not more than that. On an average, it is 3.4 kilohertz. Technically speaking, the reason why the telephone operators or receptionists are ladies is because of this reason only. because they always have high frequency compared to gens. That is the reason I said technically within course, right? Now coming to the point, at 3 kilo, now I speak with 3.4 kilohertz. Let us consider, right? What is the maximum distance my signal will travel if I don't have this mic or something? Because that is my original source. My original source is only 3.4 kilohertz. With this 3.4 kilohertz, what is the distance it can travel? Maximum up to this lab or up to this entrance? That's all, not more than that. Yes or no? But as far as underwater is concerned, I have to talk in terms of hertz. How much I have to step down the frequency? You just imagine, with that step down frequency, the signal should travel for long distance. விஷயத்தை நல்லா புரிஞ்சுக்கோங்க. The reason why we go for upconversion, I gave you example, megahertz, gigahertz, terahertz, all those things. Why? Obviously, whether you use optical communication or satellite communication or microwave communication, the baseband is not going to change. Baseband is going to be only 3.4, my voice signal. My voice signal is not going to change, but I am upconverting it to a very high frequency to very high frequency. Whereas here what I have to do, if I want to transmit my own signal in ocean, I have to down convert the frequency. Do you understand what I am trying to tell you? I have to convert it in terms of hertz, because medium, the water has that power. The medium has that power that only low frequencies can travel for long distance. High frequencies will get attenuated. High frequencies will get attenuated immediately. So higher the frequency, the distance traveled will be very less. The less the frequency, the distance traveled will be long. Now, without any modulation technique, can you tell me what will be the maximum range, or to some extent an average range that an acoustic signal can travel in water without modulation? Purposefully I put this word without modulation, because for example, if you take mammals, they don't modulate their signal and transmit. Agree? They don't modulate their signal and transmit. Now, what may be the distance that those signals can travel? The acoustic signals can travel few tens of kilometers. Few tens of kilometers. For example, if you take a mammal, the source from where it produces the sound may be 10 kilometers away, but the sound can be captured or heard after 10 kilometers or 15 kilometers. Now you see what is the distance that the signal can travel at the same time, because it produces low frequency. Whereas if it produces a high frequency, sir, busy with your mobile? Sleeping or busy with your mobile? The one who is sleeping may know that, though they pretend that they don't know. Right. So, see, in case if we just deploy our hydrophone, the point why I am telling is, I may deploy a sensor here in Chennai and I will start collecting the data. There may be some spike in the data. So what understanding we should have is that the source may be 10 kilometers away, which may not be visible to us. That is what is most important. When we work on signal processing in underwater, most important is we should know the channel, the conditions of the channel. The environment is very, very important. And as far as the environment is concerned, the other parameters are salinity, temperature and depth. This also they would have discussed. Salinity, temperature and depth. If you see the salinity of the water you collect in one location, if you go to another location, it will not be same. It will be different. At the same time, as depth increases, the temperature will reduce. And I already told about pressure. So these three are the major contributors. These three are the major contributors on what? Salinity, temperature, pressure. Now pressure exists in ocean. Agree? I already told you. There will be pressure that will exist in ocean. Salinity, நாமளே அனுபவப்பட்டிருப்போம் இல்லையா, தண்ணி வந்து உப்பு கரிக்குது அப்படின்னு சொல்லுவோம். ஸோ salinity is also there. Obviously temperature also it will reduce. As you go deep into the ocean, the temperature will reduce. Now these three are the major contributors. What I am trying to tell is these three persons are major contributors. Can you avoid any one of these fellow? So can you just tell to these three people, I am going to deploy a sensor now, so you three please take rest for half an hour. Can I tell that? It is not at all possible. So all those three will exist there. Now these three will disturb which one? They have a direct relation with respect to the speed of the acoustic signal, the velocity of the acoustic signal. Now whether this velocity of the acoustic signal is important? Yes. What is the speed at which the electromagnetic waves are transmitted or traveling in your mobile? What is it? What is it? Speed of light. So the speed at which our electromagnetic waves travel is 3 into 10 power 8 meters per second, which is nothing but speed of light. Whereas in water, the speed is 1500 meters per second only. It is not more than that. It is only 1500 meters per second, and this speed is contributed or has an effect on salinity, temperature and pressure. Now the point is, if I want to collect a data in a particular location at a particular depth, I should know what is the salinity, what is the temperature, what is the pressure at that particular location. Only if I know that, I can fit it in the formula of velocity of acoustic signal. From that I can derive what is the speed at which the signal will travel here. Without that, you cannot propagate the signal in underwater. So this is another important, one of the most important parameter, because the sonars what we use will be either active sonars or passive sonars. Obviously, as the name indicates, it is based on sound only. The signal produced will be in the form of sound only, and only sound signals will propagate. Now what I said so far for the past 10 minutes is the fundamentals of any signal that you want to transmit in underwater. Any doubt in this? Any doubt in this fundamental? It's not moving. சரி. Thought of having something about my institute, but not necessary at present. So this is what is the, நீங்க ஆப்ரேட் பண்றீங்களாங்க எப்படி? இல்ல விட்டுடுங்க. I'll just manage. The reason why we start exploring into this is very simple. See, hope you know that our planet, 70% of our planet comprises of water. The one simple question is, have we explored that 70%? Is the basic condition. Have we explored? Whereas land is 30%. Have we explored land? Almost yes. Yes or no? Then we have moved from land to, very good, space. From space to outer space. Okay, from this galaxy to next galaxy, right? And now we are thinking about whether it is possible for human life in other planets. Whereas the 70% of water which are connected together, that is one of the most important thing. Okay, so the oceans are interconnected by itself. So if you start from one place, then once again you can come to the same place, you are able to navigate properly. all these things are interconnected, whereas have we explored the 70% of ocean is the big question. Why we are not able to explore which is in front of us, whereas we are able to, because of the advancement in technology, we are able to explore which is not visible to us. Today people talk about quantum signal processing, quantum process, yes or no? You would have heard about quantum communication, which you cannot see, whereas here all these things are in front of you. You have everything in front of you, but why we are not able to explore this is the question. That is the one which made people to work in this domain, right? So basically it comprises of various layers. I am not going to talk about all those layers. We will be just classifying it only as two types. One is a shallow water region, another one is a deep water region. Okay. So because the nature of water will differ in shallow water as well as in deep water. So these are the 5 major oceans we have. Basically what ocean gives us, it doesn't give only the seafood. It regulates in oxygen production, carbon absorption, and there are many biodiversity, and like this we have various n number of applications. So the take home message is we have to preserve ocean. That's all. To be very simple, we have to preserve ocean because ocean is giving us enormous, which may not be visible. I don't want to get into this. I'll directly get into the technologies. So we have to protect the ocean. How we can protect? By monitoring. We can just keep monitoring. Right. Now have you come across this term, laws of the ocean? Whether you can become owner of this area? Why? It is in the name of someone else. Correct? It is in the name of someone else. Right? Whereas you can become a owner of your ocean. No. If you know how to explore, you can become owner of the basic fundamental law of ocean. The one who reaches a point first can become the owner of that position or that place. But you cannot take the ownership wherever you move. It also has a regulation. Okay. It also has a regulation. That regulation is what is this? Boundary condition. Right? Hope you would have heard about, if there is any issue in border crossing, our chief minister writes letter to prime minister. Happens or not? Border crossing with respect to coastal. What I am telling is with respect to coastal. So our chief minister writes to our prime minister, and prime minister of the country writes to prime minister of next country. Yes or no? So there is a law. That is number one. First thing, basically what I want to just inform you. The second most important thing is, right, I am able to see ocean in front of me, right? How I can explore ocean? Whether whoever wants can explore ocean by themselves? No, it should need a regulation. It should always have a regulation. Number 3, you would have come across various ships. Ships may be crossing the, what to say, offshore. It may be crossing sometime. Sometimes you can see that some of the ships will be in the same location for 15 days or 20 days. Why? These are the two things that we have to look into. International ships. International ships, we should always give way for the international ships to pass through our coastal region. So there is a regulation for it. And then the another one is, for example, let us consider that there is a ship coming from Singapore to us. Okay, it is a cargo ship. Let us consider whether cargo or passenger ship. Now it has to drop all the goods, and then it has to take the goods again, right? Now how much time it can hold the berth of the harbor is the question. A simple example, an aircraft is coming to an airport. How much time it is allowed to take a particular location? Obviously you would have seen that the process as fast as possible, because how much time you are occupying the airport, that much you have to pay. Yeah. Similarly, if you occupy a berth, in the ocean, you have to pay for it. That is the reason you can see that today we have private ports. We have private ports. Apart from government ports, we have private ports also. Right? I don't want to mention the names. There are private ports. Now, for example, if there are some, after 10 days only they just want to load, means those 10 days they cannot pay. So for that, we have a region where the ships will be will be informed to go to that particular location, and they will anchor there, and they will be in that position till they get the next permission to come in. இதை வந்து நாங்கள் வந்து berthingனு சொல்லுவோம். Okay, so berthing. So for berthing, we have some regulations, rules and regulations, and we have to follow all those rules and regulations. All these things are governed by international level, that is called as the laws of the ocean. Number one. Number two, I told you, see, ocean has huge potential or resources. For example, the seafood. Seriya? Now where I can explore, the reason or the problem exists because of the border crossing. இங்க ராமேஸ்வரத்தில் நடக்குதா அடிக்கடி ஸ்ரீலங்கா கிராசிங் அப்படி நடக்குது இல்லையா? Now how you can control this, or who can explore which portion? There is a question. கரெக்ட்டுங்களா? இப்போ இந்த ஏரியாவில் இருக்கிறது எல்லாம் இந்த இடத்தோட ஓனருக்கு உரிமை இருக்குது. கரெக்டா? நம்ம அதை உரிமை கொண்டாட முடியுமா? கொண்டாட முடியாது. அதே போல along the coastal region, each country has its own pioneer area, that is called EEZ, economic zone, exclusive economic zone. Each country will be provided with an exclusive economic zone, means that any resource that are available within that exclusive economic zone, that particular country can explore it, or they are the owners of it. Simple example, Dubai is rich in oil, whereas that resource is not available in our location. அவ்வளவுதான், வேற ஒண்ணுமே கிடையாது. Very simple. That resource is available in plenty in their coastal region, whereas that is not available in our coastal region. Now, can I have a plant in Dubai and extract, saying that ocean is common to everyone? No. இதெல்லாம் regulate பண்றது தான் laws of the sea. Okay. This also, it will be good if you know about this. And that basically depends on how much generally kilometers we call in land, we call it as kilometer, whereas in we call it as nautical miles. So in terms of nautical miles only, all those distances will be referred to. Sorry. So this is the, for example, from the shore we have internal waters, that is related to the land, close to the land. So from there 12 nautical miles will be the territorial sea. From that 12 nautical miles will be the contiguous zone, and from the land baseline up to 200 nautical mile is exclusive economic zone. So up to 200 nautical miles you can make use of the resources that are available. After that it is called the area or high sea. This is the place where whoever in the country wants to explore can explore. It is not given to any particular country. So whoever wants to explore, this is what I said. If you are first to that location, except the defense, and they have some criteria, who all will be given priority, except that, whereas whoever gets into the sea in that particular location, like the area, they can explore it. Okay. Now see, it is only up to 200 nautical miles, not more than that, whereas the ocean area is too big. So how we can explore, or how you can explore it, is the question. This is the economic zone for our country, India. I don't know whether it has pointer. This is the economic zone. So what are the minerals that are available in these zones? India is the sole proprietor owner for it. So what the question here is that, first thing is we should be able to identify, yes, there are some resources available at that particular depth. Second thing is we should have technology to explore it. That is very important. For example, hope some of the speakers would have said about this. 6,000 meter depth. Let us consider that I have something. Hey, if you want to go, you can go up, man. உட்காந்து சிரிச்சிட்டு இருக்கிறதுக்காக நான் இவ்வளவு தூரம் வரல. வந்ததுலேருந்து நான் பார்த்துட்டு இருக்கேன், நீ சிரிச்சிட்டே இருக்க உட்காந்து. நீ கெட்டது இல்லாமல் பக்கத்தில் இருக்கிறவனி கெடுக்கிற. நாங்களும் 24 வருஷம் வாதியாரா இருந்துட்டு தான் வந்திருக்கோம். உனக்கு சிரிக்கிற இன்ட்ரெஸ்ட் இல்லைன்னா கிளம்பி போ, ஒன்றும் தப்பு கிடையாது. So 6000 meters depth, I want to extract something. அப்படின்னாக்கா how you will extract it at 6000 meters depth? What is the technology? I told you 6000 meters means 600 bar pressure. First thing is 600 bar pressure, right? So human, just like that, we cannot withstand 600 bar pressure. Number one. Number two, I want to design a vehicle for it. Okay, it can be an ROV or AUV. ROV, you know, remotely operatable vehicle. AUV is autonomous underwater vehicle. Right? The name indicates remotely operatable vehicle means the operator will be in the shore, or he may be at the sea surface. Okay, he will be in the sea surface in the research vessel, whereas the equipment or the device will go up to whatever the depth of my interest, it will go. Now it has to be operated. Let us consider 6000 meters depth I have to operate. அப்படின்னாக்கா it has to withstand all the challenges. Try to understand. And most importantly, don't forget that the channel is a dynamic channel. 6000 மீட்டருக்கு, see, you can make a car, okay, stand on the road, standby, whereas it is not possible for you to make a ship standby in the ocean, even though it is anchored. Correct? Even though it is anchored. Why we go for anchoring a ship or boat? So that it doesn't move away. Why? Because there will be effect of wind and, correct? So for that purpose we anchor the ship. Though we anchor the ship, you cannot have a boundary for it and confirm that the ship will be only in that location. So depending upon the length at which it has a suspension, சரிங்களா, the anchor ஓட அந்த கேபிள் இருக்கு இல்லையா, ஒயர் போடுறாங்க இல்லையா, அதோடைய சஸ்பென்ஷன் லெவல் வரைக்கும் it will keep on moving. Because I think you would have come across the 6 degree of freedom. Pitch, yaw, roll, forward, backward, okay, side, top and bottom, buoyancy. Apart from buoyancy, yaw and roll. Pitch na இப்படி, yaw na இப்படி, roll na இப்படி. இது மூணுமே நடக்கும். There will be a roll because of the direction and the velocity with which the waves are. There will be a roll. See, in case if I just position a ship like this, I anchor a ship like this, positioning like this, after 24 hours, if you see, it will not be in the same position. It may be like this position, or it may be in this position, this may be in this position. Whereas you park a car like this today, after 24 hours you come and see, it will be in the same position only. This is what I am trying to tell you. Please understand. This is what I am trying to tell. So it will not be in the same position like this. Now it will be moving like this. இது அப்சர்வ் பண்ணிருப்பீங்க இல்லையா, போட் ஃபிஷர்மேன் போட்லாம் இங்கே ஆங்கர் பண்ணிருப்பாங்க, பார்த்துருப்பீங்கல்ல, ஆடிட்டே இருக்கும், இப்படி இருக்கும். அப்போ இப்படி இருக்குன்னா it will be with the same pitch. யோசிச்சு பாருங்க, it won't be. Roll also, able to understand, it will differ. So because of these three effects, basic three effects, what I am trying to tell is it will not be in the same position. Now you have to navigate your system under this condition. Do you understand? You have to navigate your system under this condition. Can you tell that there is an error of 10 degree? Can you just tell it is 10 degree error? Obviously not acceptable. So challenges in Purida. It is not that it restricts in only designing the equipment. We have to position it properly. You just imagine from 6000 meter height, okay, you have to place this fellow like this exactly, and then you have to start collecting the data. Only then you can talk about the accuracy of the data. So it needs skilled pilot. It needs a skilled piloting. You should be able to withstand with respect to what? One is with respect to the vehicle, another one is channel. With respect to the channel, now I told you at 6000 meters means, so first I should know what is the channel condition at 6000 meters. Only if I know the channel condition at 6000 meters, I can make all these corrections. I have to make all these corrections. If I don't make all these corrections, then obviously I can collect data, but there will be a benefit of doubt on the quality of the data, whether the quality of data is correct or wrong. So we have to keep all these things in our mind. This is the explanation about various zones. So we discussed a lot about all these things. So absolute darkness, these are the major challenges which people also would have discussed. One is pressure, temperature. Acoustic is the only way of coming. When I say acoustic, don't see it as a word. Please link it with respect to frequency. You have to link it with respect to frequency, means very, very low frequency. We have to operate only with a very, very low frequency. And then corrosive seawater. Corrosive seawater is for what? Let me tell an example. Hope Dr. Lata would have spoke about tsunami buoy. She didn't speak about tsunami buoy. Okay. Let us take an example as a tsunami buoy. Tsunami buoys are deployed, and those buoys are deployed for years together. It will not be retrieved because we don't know when tsunami will occur. Yes or no? So obviously we have to collect. By 2004 we are not aware of tsunami. That is the reason we are affected by tsunami. After that, there was an indication that there are chances for tsunami. How we are able to identify? Yes, there is a, and moreover, hope you may be knowing that tsunami will not occur the place where it hits. It would have occurred some hundreds of kilometers away. From the effect only we will know how much it will reach us, right? So the basic thing is, after 2004 tsunami attack only, people started looking into this seriously. Now it is not at all necessary for us to be, in fear, because along the Indian coastal regions we have deployed tsunami buoys. So tsunami buoys are totally deployed along the coastal regions of India. So wherever it hits, whatever may be the effect, we can easily identify. Identification doesn't mean we can prevent it. You cannot prevent it. ஒரே விஷயம் என்னன்னா, you can rescue. இதுதான். The identification will give you what will be the effect and what will be the time at which it will hit the shore. So within that time we can make the minimum rescue, whatever is possible, so that the casualty will not be more. At least we can save the life, though not the properties. Able to understand? So now these type of tsunami buoys will be in the ocean for days together, months together, years together. What will happen to the materials? Because already I told you, ocean waters are or sea waters are corrosive in nature. கரெக்டுங்களா? அப்போ என்ன ஆகிடும்? அஃபெக்ட் ஆகிடுமா? துரு பிடிக்குமா? கரெக்டுங்களா? அப்போ what will be the quality of the sensor that is within that system? What will happen to the quality of the sensor? This is number one. Number two, I know that many people will be working on sensor networks. How will you give power to those sensors? Because it will be there for years together. Battery, what will be the capacity of a battery? And periodically we will collect data. ஒரு நாள் லீவ் விடலாமா சுனாமிக்கு? முடியாது இல்லையா? ஒரு நாள் டேட்டா கலெக்ட் பண்ணாத, லீவ் எடுத்துக்கோ அப்படின்னு சொல்ல முடியாது. Periodically we will be collecting the data. Means it will be in operation for 365 days. Let us consider in that way. Maybe periodic in the sense one data per hour. Like that also we can collect. Okay, it is not necessary to have continuous data. For example, I tell you. Now, what was my question? Battery. How will you supply power? This is the next question. என்ன பண்ணலாம்? ஒரு ஆள் அனுப்பலாமா? அப்படியே போயிட்டு பேட்டரி நல்லா இருக்கா செக் பண்ணிட்டு அந்த பேட்டரியை மாத்திட்டு வாப்பா, ஒரு 10 நாளைக்கு சாப்பாடுலாம் கட்டி கொடுத்து போட்டில் அனுப்ப முடியுமா? That is the reason, in case if you see the buoys, on the top of the buoys there will be solar panels. There will be solar panels, and today we have almost all floating underwater sensors are coming with an hybrid of solar panel. It is embedded with the solar panel. See, what all I am telling are research potential areas. What I am telling, all these things are research potential areas, because still we are not fully developed as far as this technology is concerned. Okay, so obviously in those applications, or for those applications, corrosive seawater is one of the most important parameter which has to be looked in. So obviously when we develop any sensor, we go for corrosive free material, IP65, IP66, those type of material, and today we have advanced material. போலாம் என்ன ஒரே ஒரு drawback, it will be costly. Only thing is it will be costly, and almost see this type of research is like what to say, costly research. All this research will be costly research. Can anyone tell me, can guess any reason why? Cost is directly proportional to நான் ரொம்ப ஜெனரலா கேக்குறேன், not with respect to underwater. Cost is directly proportional to demand, quality. In a simple way, number of users. If number of users are more, cost will get reduced. Example, Arduino board, Raspberry Pi, Arduino board, கரெக்ட்டுங்களா? எந்த ப்ராஜெக்டா இருந்தாலும் இது ரெண்டும் இல்லாம இருக்காது, சரியா? Whereas number of users here very limited. Number of users are very limited. So in case if I want to have a company where I am just fascinated towards this ocean technology and I want to develop a sensor, okay, how many business I will get per year or per month? Even for per month I may not get even one business, but I have to survive for 12 months. Yes or no? So cost will be approximately 12 times more. சரிங்களா? இது ஃபர்ஸ்ட் விஷயம் புரிஞ்சுக்கணும். ரெண்டாவது விஷயம் என்ன புரிஞ்சுக்கணும்னா, I already told you, once dropped is dropped. The probability of getting it back is very low. கரெக்டா? இதுல எத்தனை பேர் தேவையில்லாத காசு செலவு பண்றோமோ அதுக்கு ஈக்குவல் இது. சரியா? அந்த காசு தேவையில்லை, கடல்ல போட்டுறோம், அந்த மாதிரி தான். சரிங்களா? அப்போ 12 மடங்குனது இப்ப எத்தனை? 24 times greater ஆயிடும். The cost will be 24 times greater. So we should be very cautious. I told now 6,000 meter depth. For example, manned submersibles. Now they are developing manned submersible. NIOT is developing a manned submersible. Okay, if you see the total cost, it will be very high. Very high because of all these challenges. அதுதான் நான் முதல்ல சொன்னேன், சார் 6000 மீட்டர் போகணும் நம்ம மிஷன், பட் அன்பார்ச்சுனேட்லி ஒரு 4000 மீட்டர் போயிடுச்சு, அட்ஜஸ்ட் பண்ணிக்கோங்க அப்படின்னு சொன்னா it is wrong. It cannot be accepted. Able to understand? So we have to work on each and everything, and at the same time we should keep in mind that we have to take not once, twice, thrice or even 10 times cautious measures for retrieving the system back. That is more important. We should always see to it that recently last month we went for a data collection, we lost our camera. We lost one of our camera, GoPro camera. Okay, the cost of that camera was 40,000 rupees. We are not able to get it. We cannot get it because we went in a location to collect the coral reefs, and the coral rocks are so sharp, very sharp. Okay, so our hand is more precious than 40,000 rupees. That will be the conclusion. Obviously that will be the conclusion. We should be safe. That will be number one. Primary objective will be we should be safe. I think Logeshwaran sir and myself, we have a very good experience in sailing. Okay, so we should be very cautious. First thing is we should be very cautious. Next is the equipment. If once lost means lost. So we should keep all these things in mind when we are doing this research. This is what I mean to say as suitable technology. We have to just look into suitable technology. I don't want to talk on all these things because it simply says that, see, we are able to reach moon. We are trying to explore whatever we want, but can anyone tell who has reached 6,000 meter depth first? No answer till now. Just 6,000 meters depth. Satellites are orbiting at 36,000 kilometer height, right? And we are making more advancements in all those things, but it is only 6,000 meters depth along our coastal region, but still it is a challenge. This is the fundamental difference. This is another research potential problem. Whoever wants to work, see, the importance in this domain is it is interdisciplinary. It is purely interdisciplinary. So whichever department you belong to, whichever background you have, don't worry about it. You can contribute to ocean because ocean is common to all human beings. You take it from that principle. Ocean is common. It doesn't say that only this group of people should come and enjoy. Correct? Similarly, whichever discipline you are, you can contribute as far as this technology is concerned. Now coming to what are the major challenges. Say today we are able to make voice call, yes or no? Are we able to make group calls? Yes. Are we able to send a SMS? Are we able to send an image? Are we able to send a video? Are you able to make video conference? Are you able to make Gmeet for 1 hour? Yes or no? இப்போ நான் சொன்னதோடைய அளவு என்னன்னு தெரியுதா உங்களுக்கு? சொன்னதுக்கெல்லாம் எஸ் மட்டும் இல்லை. Bandwidth. What I said is bandwidth. Totally the bandwidth. I started with a voice signal, very low frequency, and I have gone up to 100 members for 1 hour Gmeet. The total bandwidth, yes or no? Today, still we don't have an appropriate modulation technique that will help us to transmit 1 minute data for 6,000 meter depth. Just to 1 minute data, you just think about the images. Whether it is possible for us to transfer an image, then you just think about live streaming. Again, don't forget the point, I am telling about 6,000 meter depth. Because that is the maximum depth. I have to target for my maximum depth. If I am able to achieve for maximum depth, anything in between I can easily achieve. Yes or no? So, it is very difficult till now. A big research is going on. Let me tell you, in case if you are so ambitious, you want to become like our Ambani, take one problem in your life. That simple problem is how you can transmit an acoustic signal for a distance of 6,000 meters depth without error. That is more important. You have to transmit without error. Fortunately, you can take wireless transmission. If you are able to transmit wireless transmission, then you just see, I told you 1 minute data, then I just expand it to an image. Then you think about live streaming. Whether all these things are possible, it is very difficult because the frequency band is limited, because of which the bandwidth is also very, very limited. Bandwidth is not high. The problem என்னன்னா ஒரு சைடுல ரொம்ப அட்வான்ஸ்டா போயிட்டே இருக்கும், இன்னொரு சைடுல பேசிக் ரெக்யர்மெண்ட் இன்னும் மீட் ஆகல. Because more people should come in this domain. That is what? More people should start thinking about this domain, should start working in this domain. And in case if you come in this domain, you have n number of potential problems in front of you where you can easily work on that. So this is one of the major problems. So that is what the basic thing is. Apart from other things, the basic thing is bandwidth, signal to noise ratio. The bandwidth is limited and the frequency is also limited. So you can concentrate on how you can improve that. That is the basic difference. So far I said various challenges. Correct? In spite of that, is it necessary or is it important that we still want to work in this domain? Yes, because it has a wide application. It doesn't have limited application. It doesn't have restricted application. It has a very wide application. That is the reason I said whichever discipline you are, whichever course you study, you can contribute to this technology. There is a way for it. I don't want to explain in detail for your these are, and most importantly at present, water quality monitoring and pollution, because we already polluted land, now started polluting ocean. We started polluting the ocean. As I already told you in the beginning of my slide, our ecosystem fundamentally depends on ocean, because ocean is 70%, especially for people those who are in Chennai along the coastal region. What I am trying to tell is, along the coastal region we have a beautiful ecosystem, but only thing is we have to preserve it. Unless otherwise we preserve it, it is not possible for us to enjoy it. So in case if you want to work, you can work in any of these applications. You can work in any of these applications. It is not limited. Underwater exploration, various resources, and for your information, we have explored Mahabalipuram and Pumbuhar. Our Mahabalipuram and Pumbuhar through a DST project for 50 lakhs. It is being sanctioned for exploration of Mahabalipuram and Pumbuhar. We have completed Mahabalipuram. We are yet to explore the Pumbuhar. Military applications, there are many. Under this military application, I can give another problem statement: submarine communication. Since I belong to electronics and communication, I'm just limiting everything with respect to communication, as my title also says so. So submarine communication, you can just think about submarine communication. And today we have gliders. Let me get into this field. I just want to give you some idea on that. Hope you know wireless sensor networks. So to come across wireless sensor network, let us consider that this room as the total area. Now I want to deploy some, okay, you may be knowing about IoT, correct? We are talking about IoT, somebody said about 5G, 6G, advancement in all those things. Have you ever come across any practical implementation of IoT in underwater? Have you ever come across implementation of or Wi-Fi transmission in underwater? Because let us consider light as another source of transmission, as madam initially said, not optical. Light also can be considered as one of the source. Wi-Fi transmission, data transmission, whereas today the advancement is going in such a way that we can transfer data using our power lines. Electric power cable போகுது இல்லையா, அந்த power cable we can transfer data. Whereas have you come across all these advancements? We can just look into all these advancements. Now coming to the fundamental, there are n number of sensors that are available. Not going to touch on this. I'll just give one application. I think I'll have this. Now what is more important as far as a sensor is concerned? These are the two important things. One is accuracy, another one is precision. Accuracy and precision both should go hand in hand. It is not that it should be accurate and non-precise. At the same time, it should not be, it will be very precise but not accurate. Both should be there. Especially when we talk about underwater, the sensitivity, selectivity are the various parameters which we will look for. Sensitivity, for example, the hydrophones what we use will have a sensitivity of minus 170 dB. Minus 170 na எவ்வளவு feeble தெரிஞ்சுக்கோங்க. Minus 170 dB will be the sensitivity because it has to collect the acoustic signals, acoustic sounds in that range. Anything in that range. It's not moving. These are the various attributes. Okay, basically I'll just summarize just 2 minutes about this sound. I told you acoustic signal. Acoustic signal is the only thing. The sense, I mean the sonars what we use is, Logesh நீங்க ஆபரேட் பண்றீங்களா? One is active sonar, another one is called as a passive sonar. Basically we have sonar equation. Sonar equation depends on the three parameters what I told you. What are they? Salinity, temperature and depth. Okay, pressure, sorry. Pressure. Okay, these three parameters. Now coming to the point, what is active sonar? Active sonars are sonars which has the property to transmit as well as to receive. For example, echo sounder. Echo sounder is an example for an active sonar where we will ping a signal. For example, I want to know, I am sailing. Let us consider that I am sailing. I want to know what is the depth of the ocean at that point or in that location. How you can calculate it? Basically, there will be an echo sounder. What it will do is, we will ping a signal. The signal will go to the bottom of the sea floor. It will hit it and it will come back. From the received signal, generally we call it as an echo. From that echo, we calculate what is the depth of the ocean. We generally call it as the depth of the ocean. What is the depth of the ocean at that particular point? Here also, the depth will be represented as nautical miles. It will be in nautical miles only. As far as ocean is concerned, we don't have any term called meters or kilometers. It is only nautical miles, right? So this is a simple echo sounder. There is another type of sensor that is called passive sonars. What is the function of passive sonars? As far as this session is concerned, 90% of the recipients are passive sonars. They are only listeners. They are only listeners and they don't have a property to transmit. Right? So if I deploy a system, for example, tsunami buoy, for example, I tell you, tsunami buoy will have a tendency to receive the signal. Okay, and then it will transmit the signal to the data processing center through GPS and then through satellite. So passive sonars are used to just collect the information. What is the change that will occur அப்படின்னு பார்த்தீங்கன்னாக்கா சோனார் ஈக்குவேஷனில் முக்கியமானது என்னன்னா transmission loss. Transmission loss has to be calculated, which depends on absorption, scattering, and most important is reverberation. Reverberation is one of the most important parameter which we generally don't study in wireless communication. Reverberation என்னன்னாக்கா I have a sensor here. I just ping a signal. It goes, when it goes, it will not go in only one direction. It will go in multiple directions. When it goes in multiple directions, there may be multiple obstacles. So the signal will get reflected from all those things. It will have a huge effect. And another one most important is Doppler shift. Doppler frequency. Hope you know what is Doppler shift. It is change in the frequency. So obviously in underwater there will be change in frequency. As far as active sonar is concerned, we have to consider two types of transmission loss, because from the sensor to the target and then coming back. Whereas passive sonar is concerned, it is only one way, one channel only. So it will have only one transmission loss. This is the fundamental difference between active sonar and passive sonar. நீங்க டைரக்டா நம்ம ஹைட்ரோஃபோன் போயிடுங்க. வேண்டாம், நாய்ஸஸ் பத்திலாம் பேசின டைம் ஆகும். You can see, you can see the effect of temperature. As the depth increases, you can see what happens. For example, initially on the sea surface, it is 20 degrees or 22 degrees. Whereas as the depth increases, you can see the thermocline. It gradually reduces. Next. So obviously, when I collect, for example, if I am collecting data at 10 meters, I collect data at 1000 meter, I collect data at 2000 meter, the temperature will not be same. This is what I am trying to tell you. So at 10 meters, the temperature will be different. At 1000 meters, the temperature will be different. So that temperature should be considered. Next. Similarly, the salinity. Salinity also will vary. Next. The pressure. As already told you, for every 10 meters, there will be 1 bar pressure. Next. Next. This is the sound velocity profiler. What is the function of this fellow? I have to estimate the channel. First of all, I should understand what the channel is or how the channel is performing. So for that, what we will do is, we will transmit this fellow into the ocean. For example, my maximum depth of operation is 5000 meters. Abdinaka, I have to transmit this fellow up to 5000 meters. See to it that the signal from this fellow goes down, hits 5000 meter and comes up. So along this 5000 meters, various characteristics, how the signals are. All those data we will collect by making use of sound velocity profiler. So before you transmit any signal for testing, first you have to transmit. This is almost like an idle channel. In order to understand the channel characteristics of the channel, you have to transmit signal using the sound velocity profiler. From the profile only, you can understand what is the other properties of the ocean. Next. See, initially, how it was tested, the transmission of acoustic signal by a bell. They used a bell at a depth and then they had a receiver on the other end and they just gonged the bell and they found out that how it is able to be received. Next. This is the conductivity, temperature and depth sensors, various sensors that we use. So all these things will be fixed. All the 3 sensors will be fixed in a single fixture. And this picture will be deployed in the ocean up to the depth of our interest. Next. Now, being a communication, what I am trying to tell is, I have a sensor in my hand. I have to estimate or I have to understand exactly what is the signal I have received. So this is the basic fundamental block diagram of a communication system. Next. As I told you, there are various. See, ambient noises are nothing but generally any unwanted sound that is prevailing in the ocean or in the place where we collect the data. it is broadly classified into two types. One is man-made noise, another one is natural noises. Okay, man-made noises are harbor activities, all those things are man-made. Fishing, harbor activities, all those things comes under because of man. Aircraft, the ship movement, all those things are called as man-made noise. Whereas natural noise, wind, rain, all those things are tides, all those things are natural noises. Iceberg, ice, all those things. Now, apart from all those things, we will have various species in water. Those species also will produce sound. The reason why I am showing this is, you can see the frequency range. You can see what is the frequency range of various species we have in underwater. What is our interest of signal we want to transmit? Very low frequency. Yes or no? All these people also transmits in the same low frequency. அப்ப என்ன அர்த்தம்? There are more chances for the signal to get corrupted. Yes or no? Previous slide. Previous slide. The signal gets corrupted. The signal, actually what I want to transmit is a, but when it is in the channel, what happens? It is not because of me. It is because of the ambient sources, different ambient sources. Now, what is challenging for a person working in this is, I should clearly understand what are the sources of those ambience. Correct? Whether it will be visible? Whether it will be visible to me? It will not be visible to me. So, from what I have to identify? From the spectrum. I have to identify only from the spectrum. So, that intense knowledge and research is required. Next. Next. See, for this what we did is, I told you, no, this is the hydrophone. ஒரு நிமிஷம் மேலே போங்க, மேலே நீங்கள் இன்னும் பின்னாடி போயிட்டு இருக்கீங்க, முன்னாடி போங்க. Next slide. This is the hydrophone, passive sonar. See what it is like or not. This is what I started. It is like a coin or not. One sonar is like a coin. What is the mass? You can see it is very lightweight. Very simple, very lightweight. Now I have to deploy this fellow in the ocean. If I deploy him at 1 meter or 2 meter depth, whether this fellow can withstand the waves or tides? Not at all possible. Then I may consider that I am deploying the sensor here, whereas actually where this fellow will be? This fellow will be somewhere. Yes or no? That should not happen. What is more important is stability. I have to ensure stability. Let us consider this camera. Now, because of this tripod, it is stable or not? You just imagine if it is not stable, what will happen? புரியுதுங்களா சொல்றது? இதை அப்படியே எடுத்துட்டு போயிட்டு இந்த கேபிளை மட்டும் வச்சுக்கிட்டு கேபிள் அப்படியே தண்ணியில் இறக்குறேன் நான். கேமரா எப்படி இருப்பாரு? இதே மாதிரி கரெக்டாக படம் இருப்பாரா? இருக்காது இல்லையா? Just imagine. You see the mass of this camera, you see the mass of this sensor. Now, it is whose challenge? It is the challenge of the person who is using it. I have to ensure that it is maintained with a good stability. Stability is one of the most important parameters. So, for that, how you can increase the stability? This is challenge. Now you have a sensor, you know this is the sensor, you want to deploy at a 10 meters depth. Now you know the channel conditions also, what will be the pressure, all those things. How will you maintain stability? Very good. By increasing the weight of what? How you can increase weight of the sonar? Adding weight to the sonar, எப்படி இதை பிரிச்சிட்டு உள்ள நிறைய கல்லெல்லாம் போட்டு அது அப்படியே கொஞ்சம் மாத்தி இன்ஜினியர் மாதிரி பதில் சொல்லுங்க பாப்போம். இன்க்ரீசிங் த வெயிட் ஆஃப் த சோனார்ன்றது வேற. அப்படின்னா என்ன அர்த்தம்? இந்த வாட்டர் பாட்டிலோட வெயிட்டை நான் இன்க்ரீஸ் பண்றேன் அப்படின்றது வேற. I cannot add mass to the sonar is what I am trying to tell you. Sonar is only this much. Correct. You are correct, perfectly correct. நீ ஆன்சர் கரெக்டா புடிச்சிட்ட. ஆனா சோனார்ல வெயிட்ட சேர்க்கறோமா? அதுதான் கேள்வி. ஒயரா? You have to develop a fixture. Okay, I have to place it in such a way that it is fixed. That's all. Because the challenge is it is floating, so it should not float. So I should make it as a fixed system. So while designing the system, I should ensure that its mass is more, like a carrier signal. For modulation, why we go for a carrier signal? To transmit a low frequency baseband signal, right? Now I have to increase the mass. On what calculation I have to increase the mass? The depth at which I want to operate. So what is the pressure that it has to withstand? Puriyudungla? Next. I don't want to tell all this, the other side of story of the other side picture, because before we go and deploy the system in the open ocean, we have to check whether the sensor is working properly or not. Yenaka, per day sailing in the sea, the fisherman, the boat or the vessel what we hire, okay, they will charge close to 1 lakh. Per day they will charge close to 1 lakh. So morning by 6 a.m. we will start sailing, by 2 p.m. we will come. The reason is very simple, after 2 p.m. tide will be more. So it is not possible for us, those who are not good in navigation or sailing, it is not advisable to be in the sea after 2 p.m. So that is the reason we start. See, we will go to Ennur or we will go to Kasimedu by 6 a.m. I will be traveling from Kalambakam. So by what time we have to get up, we have to pack everything and then we have to go there. We should go there, and by 6 a.m. we have to complete all the pre-test, and then we have to get into the boat. Only if we get into the, generally we don't call it as boat, vessels. We get into the vessel. We have to get into the vessel. Once you get into the vessel, 2 o'clock you can collect the data. By 2 o'clock they will advise us to come to the shore. Sariya? Appo, if I just go deploy my sensor there and there I find that my sensor is not working, means I can come with the sensor, but 1 lakh paid is paid. Whereas if you don't sail, they will not take that money, even though we booked. In the generosity, all fisherman community undu. If you don't sail, they will not take it. Okay, they will just ask us to come on some other day. So for that, what we should do? We should ensure whether our sensor or the system is totally working well. So for that, what we used to do is, in-house itself we will check whether our sensors are working properly, the data acquisition system is working properly, the data we are able to log it properly. வீட்டுக்குள்ள என்னால கடலை கிரியேட் பண்ண முடியாது, ஆனா என்கிட்ட இந்த டப் இருக்கும், கரெக்டா? டப்புக்குள்ள சென்சாரை போட்டு I will just create some sound. மத்தளம் தட்டுற மாதிரி தட்ட வேண்டியதுதான். தட்டினோன்னா சவுண்ட் வருமா? What the sensor should capture? Sound தானே. So it will capture some. See, the simple analysis is whether there is change in data or not, value. There is change in value with respect to, I know what is the pressure I give. So like that we will do various trials. So all these things we call it as bench test. We will do it in the lab in-house. They are called as bench test. Once we have to complete the bench test, then only we should get into the ocean. Otherwise it will be a loss, big loss. Next. See, in order to maintain the stability, we went for a PVC pipe. The two sensors are fixed in the two pointing positions, 201 and 202, where myself and one of my other friend is pointing those two sensors. And this PVC pipe is tightly packed with semi-solid content. Because semi-solid content we can pack tight. அப்போ என்ன இது automatically the mass of the system, not the sensor. இதுதான் சொல்லுவார். The mass of the total system gets increased or not? Weight increases. Now depending on what is the depth I want to deploy, I will calculate what should be the weight of the system. இன்னொன்னு, for example, let me consider that you are 60 kg. Okay, you want to swim. You get into the ocean. What will be your weight? 60 kg? Correct. கம்மியா இருக்கும். எத்தனை முறை? Whether it will be same or more than that or less than that? Less than that. Half. For I'm here, but see, everything is calculation. Please try to understand. That is the only message I want to just leave. We have to understand the weight. You just imagine we are working on remotely operatable vehicle. When it is on land, its weight will be something. When it is put in water, its weight will be something else. I have to operate with what weight? Weight of the system in water. Please try to understand. I have to operate it with the weight of the system in the water, not with the weight of the system on the land. Number one. Number two, most important thing as far as underwater vehicles are concerned is buoyancy. Buoyancy is one of the most important thing. Up and down, positive buoyancy and negative buoyancy, which is very, very important. Now, positive buoyancy or negative buoyancy, you have to control. You have to control means, for example, let me consider, as I told you, 60 kg, when she goes in, it will be 1/10. So she will become 6 kg. அப்படின்னு எடுத்துக்குமே. இப்போ now I have a person at 6 kg weight naga, what should be the force I should apply on that 6 kg for her to come up? What should be the force I should apply on her to make her go down? புரியுதா என்ன சொல்றேன்னுட்டு? Then what should be the force I should apply for her to go forward, come backward, turn right, turn left? This is what is called 6th degree of freedom. Okay, obviously it will not go just straight like this. As I told you, there will be an effect of roll. இது மூணு, இதுக்கு முன்னாடி சொன்ன டைரக்ஷன் மூணு சேர்ந்தது தான் 6 டிகிரி ஆஃப் ஃப்ரீடம். இது வந்து we should be master when we are working on underwater vehicle. சரிங்களா? Now we have increased the weight of the system. Next, I have to check whether it is stable or not. அதுக்காக தான் இந்த சிஸ்டமே போணும். I cannot check it after sailing for few nautical miles. போயிட்டு சார் ஸ்டேபிளா இல்லை என்ன கரையில் விட்டுருங்க அப்படின்னு சொல்ல முடியாது. So in the shore itself we will check whether the system is stable or not. Means that up to 10 meters depth I want to collect means I have to deploy it up to 10 meters and I have to see that it is not swinging. It should be stable. It has to withstand that pressure or whatever it is. Only once when we confirm all these things, we will start sailing into the sea. Otherwise, we will just carry out the corrections. What are the various corrections we have to do? Next. This is the deployment process. I am a very poor professor. I don't have much money. So we don't have an exclusive, beautiful, advanced, technically, okay, sound equipments with us. We had only a rope. Okay. For example, I want to deploy my sensor at 1 meter depth. How will I know that sensor is at 1 meter depth? தண்ணிக்கு எப்படி தெரியும் 1 மீட்டர்ன்றது? ரோப்பு தான் விடுவேன். ரோப்ல 1 மீட்டர்னு எனக்கு எப்படி தெரியும்? அதுக்காக தான் மார்க்கர். We will have a marker which is nothing but a tape. 1 மீட்டருக்கு ஒரு டேப். ஒரு சுத்து இருந்தா 1 மீட்டர், 2 சுத்து போட்டா 2 மீட்டர், 3 சுத்து போட்டோம்னா 3 மீட்டர், 4 சுத்து போட்டா 4 மீட்டர். அப்போ எத்தனை அந்த டேப் இருக்கோ அத்தனை மீட்டர் the system is deployed. Okay, so that is how we deployed and we collected the data. This is the data acquisition system at the end. So the hydrophone, you can see a cable. Through the cable will be connected to my data acquisition system. From the data acquisition system, we will put it to our laptop and we will monitor the data. We will monitor the live data. Only then we can understand whether we are collecting the data or not. Otherwise, we will be missing the data. See, this is the wind sensor because there will be effect of wind on the data what we collect, especially in shallow water. Because wind will have its effect only in shallow water, not in deep water. If you go deep into the ocean, wind will not have its effect. Whereas it will have a high effect in the shallow region. So we will have the wind sensor. This is what is the echo sounder. I told you to calculate the depth. What is the depth at which we are? Why we need it? I want to collect the data at 10 meter depth. But I go to a position where the sea is 5 meters depth. What will happen to my system? Do you understand? I want to collect data at 10 meters depth. I go to a position and then without knowing what is the depth of the ocean, I start deploying my sensor. What will happen? Whether my sensor will go down or not? It will go down. 5 meter ஆனவனே என்ன பண்ணுவார்? ஒரு படுத்துருவார். கரெக்டா 5 மீட்டர் கேபிள் என்ன ஆவாரு? அவர் மேலேயே கீழே போவார். அவ்வளோதான். அப்போ நான் என்ன நினச்சிட்டு இருப்பேன், 10 மீட்டர் டெப்த்தில் நம்ம டேட்டா கலெக்ட் பண்ணிட்டு இருக்கோம்னு. ஆனால் என் சென்சாரு 5 மீட்டர்லேயே தூங்குவார். கரெக்டா? அப்போ if I want to collect data at 10 meters depth, I should ensure that the sea floor is minimum 10 meters depth or more than 10 meters depth. அது தெரிஞ்சுக்கிறதுக்கு தான் இந்த எக்கோ சென்டர். இப்போ நாங்கள் என்ன சொல்லுவோம்னாக்கா, ஏறின உடனே எங்களோட இன்ட்ரெஸ்ட் வந்து 10 மீட்டர் 20 மீட்டர் 30 மீட்டர்ஸ்னு சொல்லிடும். அப்போ அவர் அட்லீஸ்ட் ஒரு 12 மீட்டர்ஸ் டெப்த்துக்கு போயிட்டு சொல்லுவார், சார் ஹியர் யூ கேன் டெப்ளாய் ஃபார் 10 மீட்டர்ஸ். After that we have to sail further. Only then we will get 20 meters depth. Then we have to sail. Only then we will get 30 meters depth or 40 meters depth. Next. So all these accessories are mandatory. That is what I'm trying to tell you. It is not that only one sensor. Okay. All the other sensors are also very important. So this is another array. I showed there is one element. Here it is 6 element array. Next. This is the power spectral density. We collect the data and then we have to plot the power spectral density. So from that we have to find the effect. What is the effect of the wind? Actually this work is for wind noise. Next. So this is the professional system. Generally government systems use this type. It's a professional system where you can see a float release. This is the anchor. Saringla, weight, dead weight. We call it as a dead weight. What is the necessity of dead weight? Stability. I already told you, my system should be stable. If my system should be stable, for example, my hydrophone is still here. For example, let us consider my hydrophone is here. Sea depth is here. There will be water flowing here. Because of that, this fellow will flow here and there. Will move here and there. Okay. So I want to make it stable. If I want to make it stable, obviously I have to pull down. So for that I use a weight that is called dead weight. Pere pathina dead weight eniduvanga. Because of that, no other function except ensuring the stability. Right. Now I have deployed the sensor. I collected the data. I completed my operation. I have to retrieve the sensor back. Retrieve panna enna பண்ணுவோம் நம்ம? Retrieve panna enna பண்ணுவோம்? Very good. We will pull back. நீ இழுக்கும்போது என்ன ஆகும்? வெயிட் கீழே தள்ளும். வெயிட் கீழே இழுக்கும், நாம மேலே இழுப்போம். அப்ப என்ன ஆகும்? ஒயரு காலி, ஒயர் கட் ஆயிடும். கரெக்டுங்களா? ஒயர் கட் ஆச்சுனாக்கா நமக்கு லக்கு இருந்தா ஒயர் கீழே கட் ஆகணும். கீழே கட் ஆனா மேலே இருக்கிறதுல ஹைட்ரோஃபோன் வந்துடும். நமக்கு லக்கு இல்லை, ஒயர் மேலே கட் ஆயிடுச்சுன்னா எல்லாமே கீழே போயிடும். கரெக்டா? Can you retrieve it back again? Not possible. For that only we have this acoustic release. What we will do is, after we complete all our operation, we will send a signal from the top. From here, we will send a signal here. This fellow is like a lock. He will be like a lock. He will be like this. When I give this acoustic release, it will come like this. So obviously the dead weight alone will go down, all other parts will become lightweight, and we can retrieve it back. So this is one of the most important thing what we will be using in this sensor deployments. Acoustic release, it is through acoustic communication. What may be the drawback? அது வெறும் கல்லுங்க, வெறும் கல்லு தான் அது. நாங்களே வச்சிருக்கிறோம் லேப்ல எவ்வளவு பெரிய டெட் வெயிட். என்ன கேளுங்க, தரம் பாதி. வெறும் கல் அது. சென்சாரோட விலை 7 லட்சம் ரூபா, அந்த கல்லோட விலை 700 ரூபா. What will be the problem in this? There is a serious problem in this acoustic release. அதை calculate பண்ணி தான் அந்த acoustic frequency கொடுப்பாங்க. Problem என்னன்னா, I told you that it is deployed for days together or months together. கரெக்டா? அப்போ டெபாசிஷன்ஸ் ஆகுமா? மேலே டெபாசிஷன்ஸ் ஆகுமா? இப்போ டெபாசிஷன்ஸ் ஆகும்பொழுது லாக் மாட்டிக்கிச்சுன்னா, சொல்றது புரியுதுங்களா என்னன்னுட்டு? So you have to ensure it is not so. It should be ensured. That is one of the challenge where before they release, they will study how the acoustic system is. Able to understand? So this is what is. No, madam. மேலே எடுப்பாங்க தான். First they will just try with this. In case if it is released, it will come back. Otherwise என்னன்னாக்கா release will not work. We should ensure that it is not being contaminated. Okay, next. So this is, madam, நீங்க கேட்டீங்கல்ல, float, dead weight எல்லாம் இதான். Next இதான் acoustic release. Bottom is the acoustic release. So till the acoustic release we will retrieve back. அப்பனா எல்லாமே மேலே வந்துடும். அந்த டெட் வெயிட் மட்டும் தான் கீழே சிங்க் ஆயிடும். Next. This is an array. 10 element array. Next. Test. This is the float. Next, in our lab, we have all these things in our lab. Next. See, before we deploy, the person whom you should see is Professor Logeshwaran. Okay. So before I told you, stability, deployment stability. In the data collection, you see how these two ropes are. It should be perfectly stable. It should not be one tilted down, another one tilting up. It should be clearly stable. So only if it is stable, we can deploy it properly. Otherwise, we cannot deploy it properly. Next. This is how it will be. இப்போ பாருங்க ஸ்ட்ரைட்டாக இருக்கா டோட்டல் சிஸ்டம் இந்த மாதிரி தான் நம்ம டெப்ளாய் பண்ணுவோம். Next. We can just skip. Have you got? I just want to give one application. This is one application. What I said is ambient noise collection using acoustic signals. Uses of acoustic signal, how we collect the data. இது வந்து என்னன்னா communication. See, being a communication engineer, I am quite interested in active sonar. This is the transmitter, acoustic transmitter. You can see here, this is an acoustic transmitter. So this is another vessel. We hired two vessels. This is another vessel. You can see here. It is placed here. So whatever depth I want to just put my sensor, accordingly I have to go for this design. So I will be deploying it. For example, this sensor will be 2 meters or 3 meters in the water. So from there I will transmit a signal, and my receiver, this is another boat. So in this boat I would have deployed my hydrophone. Now this fellow will act as a transmitter, this fellow will act as a receiver. So there will be one transmission system, there will be another receiving system. Thereby we study the signal transmission, we study the channel characteristics, all those things. This is deployment and retrieval again. Next. Any doubt? This I would like to wind up. In case if you want to see the vessels in which we have traveled, these are the various vessels. We have traveled in 3 vessels, and continuously we used to travel in every year we used to travel. We used to sail. Okay. So for this we have to apply to Ministry of Earth Science through NIOT. There will be a meeting they will call for, where we have to defend for what purpose we need this vessel. What is the research we are going to do? Okay, there will be more applications. So from that they will scrutinize, and then they will finally, the panel will decide for whom vessels can be provided, because it is totally free of cost. It is totally free of cost, and the information what I received from the operator is per day vessel operation cost will be close to 25 to 30 lakhs. Per day operation cost will be close to. So in case if they have to give you for 5 days, you just imagine how much the government is investing on us just by giving this vessel. So obviously our output also should be potential. Our output or the research what we do also should be potential, and we have to defend our research, the purpose why we need the vessel. And we are fortunate, and at this time I have to thank Dr. Rajashekhar, vessel management cell head. He was so kind, and he provided us vessel continuously, because he felt that the research what I do really makes some sense, and most important is we have to give all the data to NIOT. Whatever you collect, you have to give to them. You can use it for your research, but you have to give a copy of the data to the NIOT. Okay. So any doubt with this? I am just restricting with one application. This is what is only one application. Like this we have many sensors. We have almost worked with almost all sensors. In case if you want to work in this domain, you can either approach me or my lab in SSN. So earlier joining here I was working in SSN. I have established an underwater research lab in SSN. So it has all the facilities. In case if you want to work on this, you can work in that lab also. Thank you. Thanks for giving this opportunity.
Sir, 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 thank you so much for the wonderful session. The session was very useful to everyone, from the basics to the applications that you have covered a lot. It was a very insightful session. I thank you very much. ஓஷன் இன்ஜினியரிங் பற்றி ஃப்ரம் த ஸ்க்ராட்ச்லேருந்து நீங்கள் டெவலப் பண்ண அப்ளிகேஷன் வரைக்குமே எங்களுக்கு நல்ல ஒரு நிறைய நாலேஜ் அதை பற்றி கொடுத்தீங்க, நிறையா இன்சைட்ஸ் அதில் கொடுத்தீங்க. அதில் எப்படி எப்படி நடக்கும், என்னென்ன டிஃபிகல்ட்டிஸ், சேலஞ்சஸ் எல்லாமே நீங்கள் வந்து ரொம்ப கிளியராக எக்ஸ்பிளைன் பண்ணீங்க. தேங்க்யூ ஸோ மச் சார், மிக்க நன்றி. நவ் ஐ ரெக்வெஸ்ட் Preetya ma'am, the Atal AICT Vani coordinator, to present the memento to the speaker.